Welcome back to Made Up of Wires. We are decompiling Castlevania Symphony. I was just going through. Realized I didn't clean up my tabs before starting the stream. Happy Monday. Happy Martin Luther King Day, everybody. So last week we were working on some outer wall functions. I want to take a little time and do some of that today, but I also want to look at a few more CD BIOS functions that are part of the SDK. And we'll look at a little bit of stuff there. Over the weekend, I caught part of Mottzilla's stream. He was doing a race against some other people over in the speedrunning community. You can find them in the Long Library Discord. I don't spend a lot of time over there, or any time really at all. But Mottzilla shows up quite a bit to chat. And so I thought I'd check out his stream. And we talked a little bit about the 3.5 SDK docs. So the Symphony of the Night was built with SciQ 3.5. And when you look at the different PlayStation SDKs, there are subtle differences between them. And so he was saying that he was looking at some of the 4.0 docs, and there were some differences in how some of the primitive structure layout was compared to 3.5. And that made me realize that I often pull up libref.pdf, which is available on archive.org. And the one that you'll typically find on archive.org is for, I believe, 4.4 SDK, one of the later ones. It's nice because it has more modern, I think it was made in like 1999. There's more modern PDF features, like in the table of contents, you can click on the chapter and subchapter, and it'll take you to that place, hyperlink, like we all expect things to do nowadays. In some cases, different function names will hyperlink to their definitions and things like that. I did dig up the 3.5 libref.pdf, which is more accurate, and I'll try to start using that on the stream to avoid any mistakes that might appear between the two versions of the SDK. And unfortunately, that was a much older PDF. I think 3.5 came out in 1995, and it doesn't have hyperlinks. It's already a hard document to navigate through when I'm showing it in a web browser. So we'll see how that goes, and if there's enough difference. But yeah, I did look that up over the weekend and found that version of the document. I did point out a week or two ago, thanks to anybody subscribing here and ads here, YouTube, and stuff, etc. I'm using all of that to go back into decompiling. And so one of the first things that I was able to pick up is the JP copy of Symphony of the Night. We're not actively decompiling that at the moment, but I may import a few overlays, and we can look at that as well. One of the, I think, the interesting things about the JP version is that it is the initial version, and this is the launch release, I believe, of the game. So the 1.0 release. There's 3 versions of JP Symphony of the Night. Well, there's only, I think, the greatest hits version and the original US release are identical. In JP, there's a 1.0, 1.1, and 1.2. And so maybe later this week we'll take a look at some of those overlays and see where there may be differences between what we see. And we call the HD version, the hard disk version, JP HD, if that's how that fits in with all of this as well. And then, yeah, the last thing is still planning on being at Game On Expo in April in Phoenix. The schedule is TBD. So if you are in the Southwest or happen to be coming to Game On Expo, stop by, say hi, and yeah, it'd be great to see anybody who shows up. I'm still not sure. Symphony of the Night obviously has a very loyal and dedicated fan base. I still don't know if decompilation talk at a game and anime and gaming expo, if that's going to be something that people care about, or if it's going to be like, 3 or 4 people show up and, a nice, fun, intimate thing. But anyway, we'll see. We'll see how it goes. And I'll report back later in April. So we have an ad starting soon, and let's see if I can skip that one because we're just getting started. We don't want to add. Nice news. It's not letting me snooze. So we'll keep going, and before it starts, let's see. Yeah, unfortunately, I can't. I think my stream manager may be not logged in. All right. So before we get started, I'll wait for the ad to finish, and then we can get going. I don't want to have people miss what I'm going to be working on today. Let's see if there's anything else that I can just riff on briefly. There is, so one of the things I was looking for, I've been looking for the JP version of Symphony of the Night for a while, and I wanted to find one that came with the art book. So that seems to be the big differentiator when you're getting the JP version of the game, whether Ayami Kojima's art book comes with it or not. And there's so much great things, and like art books are kind of trivial little things. Being, middle-aged dude who grew up with CDs and physical media, that it's just something that I like a lot, and so much goes into the packaging and work of something like this. So having a real hard copy of the game is something that means a lot to me. So let's go over and, actually I'm not logged in. Let me log in. So I have a branch where I'm looking at the CD BIOS function, so I think we'll stay there. What I'd like to do, I started moving some of this to SozuD's SciQ decomp repo, and Xiainamo, who started the Soten Decomp project, he also has a slightly different SciQ decomp repo started as well. SozuD is targeting 3.3, 3.5, and 3.6 SDKs. SozuD is targeting 4.0 with Xiainamo is targeting 4.0. SozuD's build system, what he's trying to do is rebuild all of the libs and OBJs in the way that they were available in the original SDK, and basically making sure that the ELF files are identical. And there's some difficulty with that in the way that the builds work. So every lib, which is what gets imported into what we are calling main, or the SLU entry point on the disk, each of those needs to be built in its entirety. So you need all of the code necessary for that. And so that usually encompasses more than one function. In some cases, I did memmove, for example. There's one function in that lib. and it can be imported. And so those, when you're building something like Symphony of the Night, only the libs that are used are imported into the game. So we don't have all of them in Symphony of the Night. We have many of them, and obviously a lot of the CD libs get built in. So those are more like static libraries, and we don't talk a lot about like dynamic loading or linking or other things like that on the project, because that's not really how a lot of the CD games were built. They were built using an overlay mechanism where sections of memory were dedicated to different parts of the game. And those are brought in manually then by the game engine. But this initial build stage for the main executable is built using static linking, or so I believe. Good evening, Dig Down Deep. So I'm gonna look at these, and I think there's about 8 or 10 of these remaining. Let's just look at the size of these and try to find something simple. So the main difference that I found with these SDK functions versus the SOTN functions is they are definitely written by very different programmers. The SOTN code, it's low level, and a lot of times they use different techniques that are lower level than we typically would see today, especially with modern programming languages. But the SDK stuff is at a completely other level. It's application programming versus basically operating system programming. So let's look for, we're going to stay in libcd, and I think there is there BIOS in here? Is CD not one of the things? Where are my, yeah, it should be libcd. Oh, I see. I'm at the wrong, it's main non-matching. The other stuff is data. So we're going to look in BIOS. I haven't done a lot of research into the structure of the SDK, except for some of the early BIOS trampolines that I looked at. What a lot of times with an SDK like this, you had BIOS functions that were built in and shipped with each of the consoles. And so if you have an emulator, you've probably gone and obviously done the work to pull your chips and extract your BIOS from your individual system, or maybe found those somewhere else somehow. And that is what shipped on the console, and unlike today's consoles with hard drives and mutable storage, there was no way to update that once it shipped. And so different revisions of the PlayStation had different versions of BIOS with bug fixes and other things like that. But for games that came out afterwards, they needed different versions of the SDK, which would patch those bugs, and those bug patches then would be built into the game itself. And so instead of directly calling a BIOS function, especially for things like libc, they might call a function that just exists in that game. So I'm going to try to find something of reasonable size. I did kind of want to look at so we do have some data here, and I'm guessing this is data as well, this AID BIOS. I think that's the build information. I was kind of interested in this callback function and what this does. So let's start here. And if we can get through this one quickly, then we can move back to outer wall. So I'm copying that and going into decomp.me. There was a question in YouTube comments about what we're targeting, and I think early on I probably was better about kind of repeating what we're doing every stream, and do that less so now. So Symphony of the Night was written in C. We're trying to reproduce C code that will compile back to exactly the same assembly that we find that was shipped on the disk. And to do that, one of the tools is decomp.me, and decomp.me gives us an editor for C, which will use a compiler of our choosing. In this case, we're targeting GCC. Actually, I wonder if... so SciQ 3.5 wasn't a preset earlier, and I'm somewhat interested in if that is a more optimal preset for Symphony of the Night now. So we were targeting GCC 263 because that was available. But now that SciQ 3.5 is also available, I don't know if that's different or not. That was maybe 6 months ago or so that somebody found that. So first we need to get this compiling. And I want to get a bunch of these function signatures that we don't have. So these are part of libref. I'm going to find, since I have it now, my 3.5 libref. And I will show you what I'm looking at. Maybe. The one unfortunate part of these is that, there we go. These BIOS functions, they may have shims for compatibility with the PSP, but for the PSP version of the game, we don't have a way to reference these. So I'm going to be looking for CB Ready and CB Sync. These may or may not exist. And they also may just not be easily searchable. I believe the CD library is in the 2 section, but that could be wrong. Nope, that's libc. So I'm going to be doing a lot of scrolling. Apologize if this is too fast. If it is, please post in chat and tell me to stop. So I want the table of contents. We're going to be looking for the CD and streaming library functions, and that's section 9 of this manual. If you've watched before, usually I can click on these and it'll take me there, but not today. And for whatever reason, as I said before, search does not work in Safari either. It works when I open it in preview. So I'm a little surprised that it doesn't work here usually. It works everywhere or not at all. Section 8 is long. Section 8 looks like... Oh, it's not GTE, just extended graphics. Okay, here we are at the CD. So what I'm looking for is any of these. So CD be ready. It looks like the CD underscore are the private implementation ones. So let's look at CD ready. And often these have a similar signature. So I'm going to go down to page 37, 937. And so we have an integer mode and then a result, which is just a pointer to a buffer. And so let's this is a little different. So we're passing in this 9268, which we don't know what it is. We can either start by decompiling these first, or make some assumptions here. And so I'm gonna start by making assumptions. We're gonna just assume that this is a character array and that it has the same function signature, and then the mode was an integer. And so we'll say that this is an integer as well. We'll have to look at how these arguments are set up and see if that's the case or not. So CB ready is callback ready. CB sync is callback sync. And I guess I'll leave them as a unsigned 8 for now. And I'm going to assume that this is a character array as well. And my guess is that it's this that's being passed to callback sync. And these may return an integer, they may return void. Let's say int for now. And if that has to change, that can be fine, or that will be fine. I annotated that wrong. And screwed it up again. There we go. Hey, Mr. MIDI, good to have you back. So we're at about 76%. This is, like I said before, this is going to be a little bit different from what we normally see. So we have a bunch of globals that are maybe volatile, may not be. We'll figure that out in a bit. It looks like we're getting an interrupt value and then checking that value. So let's call temp v0, just call it inner for interrupt or interrupt. Hey, Antoine AC, good to have you. Welcome. So we have a loop out here, and I'm trying to see where. So our loop is based on whether or not the interrupt is zero or not. So basically we're spinning on waiting for one of these conditions to happen. It seems like specifically whatever flag 4 is. I'm not sure why. Okay, so we have these two cases where we're setting interrupt this var v0 to a mask of the second bit here, and that's likely because of the delay slot in this branch. M2C is not figuring out that it's the same thing. And so I don't think we need two different cases there. Temp S1. Temp S1 does not seem like it needs to be read first, but possibly does, because there may be something else happening here. So what I think I'm going to do first is try to rewrite this loop as just a while loop. Basically, we're gonna break out of the loop if the interrupt's 0. But the loop still has to be a while true. And if interrupt is 0, then we're gonna break. And then we can get rid of the goto. And I haven't been checking the match too closely while we're going through this. So let's see what else we need to figure out here. So this offset of 8.1 is being loaded much earlier. It's being loaded before before this is loaded. So it seems like this is going to be the mode. And what here we're loading it as a byte, but what is actually happening is the address is being loaded, and then we're accessing the 0th element of that. So let me go back over to the other CD BIOS code. There is like this CD flush struct, for example, that may have the structure that we're looking for. And let me see if we've seen this address before. And we have, so all we know is that it is we're currently treating it just as a byte array. So I think but what I was interested actually is this 8.1. Let's see if that 8.1 is being used. And that is as well. But 8.2 is as well. So we worked on this flush function earlier, and it probably is worth looking at. Well, there's a couple things I see here. The CD flush struct is ABC, but then we have a reference to 8.1 that's not actually being used. So first we need to grab this this offset here at 8.0. And instead of using this 8.1 and 8.0, this actually tells us a little bit about what these are as well. We're going to use this struct that is being used now for more than just the flush. So we'll take this and we're going to grab B here, and we're going to grab A here. And I'm going to change these to int and see if there's any difference there. And then this 8.0, we need to get rid of 8.0 and 8.1, and we should have immediate differences here. Oh, that fixed it. That was all. We didn't have to do anything else. So yeah, it was just struct access that was preventing the match. So here we have an immediate difference where instead of grabbing the value from 80, we're grabbing it from 80 plus 1, which ends up being the same thing when it gets compiled. Drat. Wrong window. Backing up. All right, so here's where we were at 86%. So I brought in the that CD flush struct, which I'm going to have to rename to something else because it's obviously being used for callbacks as well. It seems like this is maybe a mode. A is the mode for sync, and B is the mode for ready. But we can look at those. This went pretty quick, so I think we can look at those next. And then because we have this new definition for 80, we're going to get rid of that and the next address over, which is for B. And the address for 81 is going to be field access B, and 80 is going to be field access A, and that gets us back to that match. And so, like I was saying before, 80 is 80 plus 1, which is what we get here, and we have an immediate difference because decomp.me doesn't know what these addresses and offsets are, but we do, so that should be fine. So let's take this back over and see if we get a match. This was callback. So I see right away that the type for callback above is incorrect. And so we're going to have to fix that. Function pointers are a little funny in C. That should be enough. I think get interrupt may have a different signature. For the SDK stuff, I don't really like using the S and U types because that's not how they're defined in the SDK docs. And so I'd rather use like the ANSI C types. I don't see any other definition for it, so that should be fine. So let's see if this matches. So we have a few of these where our types are mismatched, and so we can go through and try to fix those. There's two ways we can do it. It may be easier to do on the decomp.me side because then we can see if it breaks anything along the way. But let's see what the types are here. So, okay, so these we know are wrong. CB ready and CB sync, those were just put in as placeholders for that structure. So we'll get rid of those and add ours. And I like using an explicit null then, since we know these are pointers. And then the other ones I think were these 260 and 268. Oh, not that one. D80. We don't need a second definition for that, and we don't need a second definition for the struct flush, or flush struct. And what else do we need? D68. So here we have it as assigned 8. Let's try that in decomp.me first. As long as it doesn't make a difference, and it doesn't because we're just using it as a pointer. So that should be fine as well, so we can get rid of that. And we have a match. All right. So we fixed some stuff that hadn't been figured out yet, and we were able to... Why is decompiling the SDK important? Good question. It probably isn't for porting, and it isn't for modding necessarily. There's a couple different projects though that I think are valuable. So if we have an open version of the SDK, technically the SDK itself is owned by Sony, and you could only license it if you were somebody who, you know, had an original SDK license with Sony. And so maybe there are some people, like I have a what is it, a DTP T1000 for the PSP. So in the US, if you have possession of something, it's yours and you can do with it what you want, regardless of copyright. I mean, I can use it for personal use, regardless of copyright. Other people don't have, and I mean, how many PSP development kits are there? Not very many. So how many people can have those and use those? Not very many. So by us decompiling the SDK, people can make new games that are compatible with original hardware or emulators. We know more just about what what was going on historically. So preservation, I think, is very important. And then, to a lesser extent, but also important, when we get to, or people who are interested in the porting stage, we do need something like what Konami had with their compatibility layer for the PSP version, where we can compile the same SOTN source code, but link it against something that's source compatible. And having the signatures may be enough, but having the code there as well gives you just a little more insight into what that function does. So that's some of the reason why. It's just a little bit different as well. It's kind of nice to look at some of these and see what else might be going on. Let me see if there's anything else in there that we can do quickly. We can look at the volume function quickly. And see if there's anything there. And then we'll move back over to outer wall. If this is more complicated than a few, maybe 10 or 15 minutes, I'll just move over to outer wall anyway. All right, so I'm going to new scratch. I'm going to mark this one as matched. Where's my override? There we go. And the obligatory celebration. That requires too many clicks. Oh, this is a toughie. Not really. This seems straightforward. We'll see if it is or not. So it looks like we have a struct or array with 4 somethings in it, and we'll see what those are if they're, looks like they're bytes. And then we have a bunch of these definitions already as well. Yeah, it's a change of pace. It's nice to look at other things. Obviously, there's a ton more SOTN to do, so there will be no end of SOTN decomp. And let me get back to where I was. So we need this definition for D6.8. And let's see if we have a definition for D6C. D6C seems like it may be part of D6.8. Maybe not. We could look as well in a debugger and see what's at those addresses. One of the other interesting things that I found while doing this and looking at so Sozu's decomp project, it's taking and disassembling the libraries from the SDK itself, and the offsets, because those libraries need to be relocatable, are sorry, I'm looking at the wrong thing. Are all kind of relative to that object. And so there's enough information then in the ELF file that gets built that they can be reconstructed and relocated when they get linked in, which is kind of a neat thing too. Not necessarily knowing everything that's going on with that. So I'm gonna take a flyer and say that this is just an unsigned 8 array, and so then each of these is just going to be offsets into that, and it may be that same structure that was in the other one. I'm not sure, but we'll see how this treats us. Get it compiling, and then okay, so this worked. I am gonna bring in this. I didn't even show you. Again, my screen management is off. So this is how things were after bringing in all the types, and I just changed these to array offsets, changed the type to a array or a pointer, and that worked as expected. I do want to look and see, is it possible that this could be this this same struct type? We'd have to add a 4th field there, and then we can change these to ABCD. I doubt it. Thinking about it a little further, these likely are audio channels, and so this may be the and the other ones definitely are not. So that works as well. Let's look at libref and see if there is a structure that takes volumes or is related to volumes. So there's filter, ST header. No, I don't think it's any of those. Let's look at what they are. So audio attenuation structure. Yes, this is actually what I was looking for. Possibly. So it may be this attenuation structure. And let's see if that is already in the context. I don't know if that has been imported for anything else. It has been. Let's change that, and those fields are pretty easy. I don't know for sure that that's what it is, but that, if not that, it does seem like possibly some other volume struct. The other thing we can look at too is basically the 6870 and 74 appear to be like a mode, and then left to right channel volumes, and again mode, left and right channel volumes, and then something else at the end, maybe some flags. Looking at libref, do we have something like that? Not CD location or CD file, and that is also file, not CD location. ST header is much too long, and yeah, so the rest of that is missing. So one thing we may have as well is one of these enumeration tables may tell us what the hex 20 is. The highest this goes to is 1C. This might require skimming through a lot of these. So this was related to volume though, so let's go specifically look at the volume function. And do we not have one that is maybe mix? Let's look at mix on line 20 or page 27 of this section. So it does take this attenuation structure as its argument. So I think that's a pretty good indicator that that's what that is. The CD mix function always returns 1. Our function here always returns 0, and that is if this was a void function, it would be a no-op. So we can get rid of this as well. So what we don't know yet about this one though is what are these? One thing that is, I think, worth looking at here, and the reason that 6870 and 74 are all volatile, and when I was working on these on the stream last week, I talked about it as well. Usually as application programmers, we're thinking about memory addresses as something in RAM, but these are hardware mapped memory addresses, and so when we're writing to this, it may be going out to sound processor, it may be going out to like the CD controller, things like that. And so when GCC is coming through and doing an optimization pass, it's going to see you're writing to 6.8, you're writing a value 2, and then you're writing value 3. Yeah, it could be, yeah, DMA, things like that. And so an optimizer, if this was not volatile, would just completely eliminate all of this, because before this function ends, those are being overwritten. And because they're being overwritten, what does it matter what the previous values were? Nobody else will ever see them, depending on what your memory model is. And in the mid-90s, non-threading single execution memory model for C, this function is going to run to completion, and nobody else will see this these internal changes. And so we mark those as volatile to say, no, it really is important that you write those regardless of whether or not they're being overridden, because it's not something that that's just this function, it's hardware. Yeah, it isn't interesting. The hardware side is very foreign to me. So Mr. Midi saying, you know, it is interesting to see how hardware is handled. I know the original PlayStation, or I know from what I've read, the original PlayStation shipped with a very high-end audio processor, and some people argued that it was kind of audiophile level for CD audio. For CD DAC, it was excellent. The first time I rented a PlayStation was one of the originals with the AV jacks on the back, and then later on, a couple of years later, when I bought mine, it was enough revisions later that they had gotten rid of all that, and I was very disappointed because it was nice to have everything just right there. I don't know if my current one, I don't have it in here with me. I eventually got one of the original models. I don't remember though if they took S-Video out, or if that was only Japan. I don't remember. All right, so let's see. We can get rid of these now. And what did I scrub? Oh, we don't have a header file necessarily. Is that what's missing? It looks like I screwed up some types maybe. So I'll need to bring in this CDL ATV header, which is in libcd. What else did I screw up here? I think I will change the return type to a plain int. Yeah, I screwed something else up along the way. Let me revert what I... Yeah, I didn't get this building again. I see. So I pasted somewhere in the middle of that. So I do need that include. And move these up. And T6C, that is moved up as well. And we can get rid of another one. See a match, and we got a match. Okay, so that's all we'll do with libcd for today. We'll add that to what I have, and then fortunately my N01 branch is broken. So let me see what I have. I'll go to my N01 chair branch. So N01 chair, if you were watching last Thursday, I was having to break up a bunch of oh no. Do some more splits, and that ended up being more challenging than I had thought. So when we don't have a file completely decompiled and only partially decompiled, if there's RO data that's getting generated part of the way in, we need to possibly split a file so that we can force alignment of certain RO data where we want it. And that's what was happening with the chair. There was certain things in the main chair entity needed RO data aligned at a certain place, and so when it was decompiled, it needed to be split. And for the chair, that's okay, because it's its own entity. It can live in its own file, and that's fine. But then there was stuff after the chair that needed to be split as well. And for whatever reason, I spent a long time over the weekend trying to fix these splits, and I don't know why it took me so long, but it's done, and they got split up. Hey, Project Oblivion. Oh, Project Oblivion says he identified a bunch of N01 things. Good to know. I don't recall what we left on. I think we were working on one of the birds or the eggs or the nest or something down in the ark. We'll see if any of that's still there. Can you please poke lib a bit? I want to understand how to dedupe RO segments. Poke lib. Can you enumerate or expand on what you mean? I can undo this split and show you how I did the split, if you'd like. Would that be helpful, Mr. MIDI? Or we could do a different split. Library. Library's added? Okay, great. Let me just make sure. I think I rebased, and let's see if I can just do an extract and make. And yeah, I know I saw yesterday, or maybe earlier in the weekend, that there was talk about adding a new overlay, but I didn't see that a new one was added. Library is a good one, and it might be fun to find the librarian entities. Stay away from the ectoplasm entities. Oh, both are coming in? Okay. For people who can't read the fine print, Mr. MIDI mentioned that the PSP and PS1, US PS1 versions of the library are being brought in. And so that actually introduces somewhat of a challenge. When we're decompiling, we need to make sure that it builds for both and we're matching both. Previously, we'd bring in we'd import the PS1 version, get that compiling, and then if somebody wanted to bring in the PSP version later, they needed to go back through and basically redo the same thing for all of them. And I think what we'll probably do to start then is start with the PSP versions. And this gets into, this will be a little tricky because we have to do it on both sides, everything twice. But we can do that. So let's look at some splits. I'm going to open up the... Yeah, we can always put in if-defs and limit it to one, but as long as we're here, we may as well. do the same. Do them both. So we have a bunch of unknown here, 4C05 and 4F918. I'm going to go through and see. So I'd written a tool. So I know that we have the dupes tool. And let me see if that's working again for the published version. It takes quite a while to run, so I'm not going to... maybe I should run it in the background. The published one has been broken. But it's a good way to... Yeah, it's still broken. Oh, no, it's not. No, it's not. Okay, let me show you. So here is the output of the dupes tool. So we do have a match here. So here's the chair. And what we're going to do for this is, this is actually a great place to talk about splits and also sharing code between multiple overlays, which is all tricky. And it's always good to do this with anything related to these common shared entities. So we can start there. So we know that the 8008 function related to the chair, this is a real simple function that is just telling you if you're pressing the up button and you're within the range of the chair. And then that's going to be the same as BEDD8. So we'll give this function a name as well. 2 chair instances. That probably is fine. Let me look. The other chair doesn't match, and this is what I found when I was looking for it. So we might not be able to share this completely. We'll find who is calling this BEDD8 function and look at that as well. But we can break those out into their own file. So I wrote a tool and modified another tool to extract the functions, mask them, and then grep for them. And what I found when looking for the main chair entity function was that it only matched in N01, which was a little surprising to me. So that tells me that different chairs have either different implementations, different behavior, or something else. We'll figure it out. So let's start here with this BEDD8. And first I'm going to look for that in lib. And we'll open that one. And the function immediately after it should be the chair function. Give me 1 second here. Control W plus was supposed to change my split size. Let's try Control V underscore. Let's go 120. Nope, that's not working either. Oh, Control V type. That's slightly better. There we go. All right, so we're here. So what we want to do is split and get these two functions into their own file. Unfortunately, there is this other one, FE or EFEC down below, and that's probably going to be something different. So what I'm going to do is split, I think, that one first. And so first we need to know if there's any RO data associated with that. And the easiest way is to just look at the assembly. Typically, any RO data, there'll be two types of RO data. One is like string constants or struct constants, and the other will be jump tables. So we want non-matching, first C file, and then we're going to look at this FE. And so we don't have anything here. It definitely is possible that this is also part of the library chair implementation without decompiling it. We don't know yet. And then I'm going to look at this E38 as well. And I expect E38 to have a jump table because that's what the N01 chair had as well. So it has a jump table and more. And so we want to look at these RO data addresses. And so we have this 980, 990, and 9B0. Those all come consecutively. And so that should be fine as well. So I'm going to first split off this BEFEC. And so Project Oblivion is mentioning that there are two chair instances. Yeah, and the other one is not there. Let's see if the other chair instance calls this DD8 function. I am referring to the right one, right? EDD8, yeah. So it looks like only E38 calls it, which is interesting. So we'll have to look at that 9028 function as well in a little bit. So first I'm going to split, like I said, I'm going to split EFEC, and this should be an easy split. It should just be a single C file split. And the only, I mean, I'm numerically dyslexic, so this is hard for me. As long as I copy and paste, I should be fine. I'm going to name it using this unknown underscore strategy. I don't know if I like that strategy, but that's what we're currently doing. So there's two things I could do right now. I have to extract anyway. The easiest thing, in my opinion, is just to get this out of the first C file. And now when I run make extract, a new file will be created for me, and it will be 3EFEC. So let's try that. And as long as I didn't do something stupid, this should compile and it should still match. And we should have a new file when this is done. So Splat is looking at the splits. It's looking at each of those segments and saying, does this file exist? And it should extract anything that it finds. Let's make sure that it created this file. If it doesn't find that file, it should create it, and it did create that function, or that file. Let's run extract one more time. I would have expected it to have done the extract when creating the file, but maybe it needs a second pass to do that. So the way Splat is set up, it's going to be looking through each of the files that include ASM macro, and when it finds a match for that file in that segment, it should extract that function. Oh, this is the problem. We use a slightly different naming convention than Splat likes, so we do have to change this file a little bit. Forgot about this part. So because we're using the same source for multiple versions of the game, there's a bunch of things that Splat was made for the Nintendo 64 specifically. And so there's some assumptions that it's making. It's making the assumption that you're building into a single binary blob, and that, in this case, that your assembly is all being extracted to the same place. Neither of those are correct for what we're doing. So some of it's tooling issue on the Soten decomp side, integrating better with Splat. Not sure why all of this is getting rebuilt. I may not have. Okay, so we're building fine again. So we have this new 3EFEC file. There was no RO data here, so there wasn't anything else that needed to be done. Now we're gonna do the chair, and there is RO data with the chair, so we have to be just a little bit more careful. And I will open this. So I need the offsets that come from this file, and Splat will actually tell you this if you look at the Splat output. So let's run. I could do run it specifically, so I'll do split on this file, and it's going to tell us, I think your RO data segments are here. I think your RO data segments are here. I think your RO data segments are here. And basically it's telling us where it thinks the file splits are. And those are likely correct. And so we have RO data that starts at 2D980. If we look at that output, my guess is that it found 2D980 as a potential place for a RO data split. And of course, it's going to prove me wrong. Often those will be the where it says to split. So it's not saying that there's a split at, or it didn't discover a split at 2D980. The heuristic that Splat uses, if I recall correctly, for these is, let me just double check this one more time, 2D980. The heuristic that it's using is there null bytes that are appearing on an alignment boundary? And if it sees that, it says, oh, I think that this is probably a different file, and those null bytes aren't being referenced by something else. So there's no load that would load those bytes. And there's a smaller data type that comes before them. So that's where it gets its list. It is definitely possible that this just happens to fall on an alignment boundary, but there is one other thing that we can check beforehand, and that is what comes before 2D980. This is a little more difficult to do, but we don't need to shy away from the difficult. So what I'm going to do is look for the 32-bit address immediately before this. So that will be 2D97C. And see if that is referenced specifically before, and it may be, it may not be, I don't know yet. I'm just trying to determine where other RO data is, and if we can tell where that split might be happening. Normally I wouldn't do this. I would just assume that it's 2D980, but I'm going to be a little more thorough this time. So we don't want to look specifically at non-matching. It may be showing up in the data segment as well, or the data directory. So I'm just going to look for that, and that doesn't show up. So I'm going to look for any hex character then, followed by a space, and preceded by a space. And so we do see in the first file, RO data segment, that there is stuff there, and specifically at 2D974. And so I'm going to split there. And so so we have the repeated RO data that got associated with our chair functions. And then we have the misspelled dummy set. I'm glad I'm not the only person who misspells things that get committed. This is committed to history, though. And so Soten Decomp will always include the dummy set. So dummy set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. And so that would get us to 97D. E, and then the null byte. So yes, this ends up being aligned. So then let's look at where this 974 is being used. More tabs, always more tabs. My web browser is a disgusting, miserable pile of tabs. So we have this referenced in this as RO data in this first first C file, but it's actually not referenced anywhere else. Let me see if it just happened to be something that has already been decompiled. Oh, I missed it. My bad, I missed it. The line scroll, I thought it was a different output. So BED48 is where that string is referenced, and that is the function immediately before what I think is the beginning of our chair section. So we're safe. RO data is starting at this D98 RO data segment. Mr. MIDI, is that I used to use links quite a bit for testing like accessibility before like ARIA and all those things existed. But not anymore. Not anymore. So Mr. MIDI, is this so far something that can be followed? So my next split then is going to be at the BEDD8 function. We have to subtract 80180000 from it to get our offset of 3EDD8 for the C file. And we'll call that chair. And now we need a split also for the RO data segment. So we're not going to be in first C file anymore. And our split there is going to be at 2D980. And so when there's a dot, except for the C files, for whatever reason, when there's a dot, that means get it from the compiled object of the same name, so the .o file of the same name. And that's going to be eChair as well. And we can do the same thing now. We can get rid of these two functions, or these two include ASMs. We can run a make extract, and then we'll get the chair file, the eChair file. We'll have to fix that file, the pass there, and then we can make again, and it should make. And because we have that that first function decompiled, we could probably pull that in without having to go to decomp.me and get a match there as well. And then look at the next chair implementation and see what might be causing issues and preventing a match. So we have those like we expected. And we can get rid of the ASMUS and make. And I should have done a make J, but we matched. So we have our chair file. To prove that it's actually matching and not something else, I can get rid of that and break it. So that's good. And we'll do a split with N01's chair. N01's chair. Let's go. Not eCollect, eChair. There we go. And we'll grab the sit check function, and this should we'll need to include lib.h. We might be able to get away with common.h, but it'll need lib.h eventually. And then we can build that, and oh, is there no lib.h yet? Okay, so let's keep common.h then. So we need something more than that. We could do game. That's going to be too much, but it should be fine. Oh, I copied and pasted too quickly. We should give this a name now that there's two instances of it. But that matches as well. And we saw that it didn't work. And I can change something trivial here to show that this is what is compiling, and that breaks. So we were able to split that and match it. And then since we're here and split, let's look at this other function. And we'll go over to decomp.me, and I think I'll we can start with the other chair implementation, and yeah, it's odd though that they would be that different, that that duplicates wouldn't find them. So I am gonna start with the other implementation and see if so. Right off the bat, there's additional debug logic at the bottom here. that doesn't exist in the other. Excuse me. It's easier for me to copy the whole file, so I'm going to do that. Get rid of these. And so I'm going to take the top of this and replace it. And then we can come back and see if there's other things that need fixing as well. And so it could be that maybe we can share these with a... so we need the chair entity. Which I don't have in my context yet. I did want to find, so the entity has one field, as far as I know, and I wanted to find too far. It seems like the timer for Alucard falling asleep, but something other than the chair itself is doing that calculation. Uh, 63. I'm looking at the... Did I call it something different than unknown 2C? Oh, unknown 0. It's the local offset to the extension, and the extension starts at 2C. So we have immediate differences. There is this init common is the wrong type. It should solve that. These are all correct. 63. Maybe 2C. Maybe I'm wrong about 2C. Uh, 2C is step. I was wrong. So I think that's it. I think that's the only difference. So the library version prints some additional debug info that doesn't get printed there. So I think adding an ifdef here called like chair debug or like include chair debug probably is enough. So let's I'm going to go back to Vim, and what I'm going to do here, instead of copying from decomp.me, which would be the smart thing to do, and you know, an intelligent human might do it, I'm going to take the other implementation, paste that, and just add those debug lines to the bottom. And so now what we're going to get, which is really nice, is strings automatically get pulled out to RO data. If you ever do see a string in RO data, and something referencing, like if you have a global and that global is pointing to RO data, and you can tell by that the string is in an earlier memory address than your function is, that's the kind of the tell. Usually, not always, but usually that means that it's an inline string in the function. And so I've seen a couple places where people continue to reference it as if it's external global data, but usually it's just implicitly RO data. So we should be able to make, okay, we're referencing the wrong thing. So we're gonna have to rename these things. to point at the right version of the function. So I think this EDD8 or 8008, depending on which one it is, should be called like check sit action or something along those lines. Feel free to chat and tell me what it should be called. E3, what is going on? What's going on? Oh, I can't call it entity chair yet because there's other data that references it. So I'm going to go back to the old name, and then we can fix up the addresses. I think that's about all we'll have time for. So that's matching as well. So let's see where this function is being referenced. If this data hasn't been pulled out yet, then we'll just have to set it in the symbol table. So here I want to look there, and I want to look in ASM. So if there's any references in ASM, yeah, we'll have to set it in the symbol table. So here's our address, and we'll call that entity chair. And then the other one can be static because it's only referenced by this function. So I'm going to close the N01 chair. Symbols US STLib. And I usually add them to the bottom and then let the linter pick up the right one. And this is somewhat of a pain. I usually use touch to update the timestamp on the splat config, and then run make extract, and this should overwrite the other assembly that's been extracted already, but I feel like either I'm doing something wrong or we have something else going on, and those don't always get updated, and then I clean and then I rebuild the whole thing. And so is it going to take me 15 seconds to do this, or is it going to take me 45 seconds to do it? Usually it doesn't make that much of a difference. All right, so we have an undefined reference to entity chair in lib. And okay, so we got to keep things in sync. That's because here we didn't call this entity chair, so we're missing that symbol from the final built objects. And we're good. So the last thing, let's see if we can. Now it doesn't matter because it doesn't matter what this helper function is called because it is static. It can't be accessed from outside of this, so we could call it whatever we want. There's no symbols referencing it, but we do have this entity chair symbol that we can use. So I'm going to create a new file at the root of the stage directory called eChair, and we make these header files because we don't have a way to build these in a way that can be shared and relocated at link time. So I'm going to take these and move them over. Usually, for better or worse, we don't include all the dependencies. Part of that came from some header include guards that were missing early on. What do we need here? We need player and pads. Let me just see where those are. I like having these be completely self-contained so you can include them without really thinking about doing any of that. Oh, that's in game. So I'm going to add the game header, which is less to include later on. And then here, in our lib file, we can include, we'll do eChair, not to be confused with Ichiro, and save this as well. And build again, and this should match, which is good. And now what we want to do is make this conditional. So we'll say if def chair debug and then define that, and this should still build fine. Yes. And then we'll go to N01. My guess is that this lib version, the library version of the chair, is oh, and down here we don't need game.h anymore. And here we should just be able to include eChair. And that should work as well. And it does. All right, so now we have a shared chair implementation, which is what I was hoping for in the outer wall. Odd that these debug lines don't show up in that other function. It's possible that there's other debug code in the library that we'll come across. My guess, though, is that this is now going to be the common version, and unfortunately, the way that I have my my grepping tool set up, it would take too long to do that on stream, but maybe I'll set that up this afternoon and show that tomorrow, and we can see if this implementation exists somewhere else. What could I do? I could trim off the first part, everything up to the return statement, but I won't do that today. I'll do that tomorrow because my time is up. So we got 2 of the CD functions, which is awesome. We got a shared chair implementation now, and we went through and did a bunch of splits. I'm going to make sure that all of this gets added to, so we want eChair, we want the shared eChair, and we want our new unknown, thank you, autocomplete. And we should see, we still have a bunch, symbols and BIOS and other things like that. We'll have to add all those as well. But I think I'll submit this for a PR. It looks like nice and self-contained for these N01 changes. So Mr. MIDI, I hope that helped with some of the splits. I know I went through kind of fast, and fortunately this time the splits worked out. And coincidentally, I was just splitting over the weekend in this same space, so I knew some of the things to look out for, and it turned out this one was pretty straightforward. So yeah, I'll add all those, the symbols, the splat config, and get those checked in. And yeah, this is I think a pretty well-contained change for the library. If you want to know more about the Symphony of the Night decompilation project, go to soten.z.dev, join us in Discord. Mr. MIDI's there, and Project Oblivion, he's there as well. You can join us, show up tomorrow, and Monday through Thursday I'm here from noon Pacific time for about an hour and a half today, a little longer, but that's okay. And we're going to keep decompiling Symphony of the Night. If there's specific things people want to know about, I really appreciate the suggestion from Mr. MIDI to talk about splits, and it was very relevant for things that we were doing recently. Yeah, feel free to chat if you're watching on YouTube. Comment, and I will try to address them when I read the comments. That's all I have for you today. See you all tomorrow. Thanks for joining. Adios.